Starting to record. Okay, good. So let us look at question number 9 in the problem sheet. Okay, so let me share the screen. Is it visible?
Yes, sir.
Okay, so in
Yes,
this,
sir.
one hint that I can give you is that, wait, let me explain how this problem is solved. 1 minute. Huh?
Sir, you're not audible.
Is this PowerPoint visible?
Yes,
Yes.
sir.
Okay.
Yes, sir.
So the hint that I can give you to solve this problem is that you can assume that this length that I'm showing with my blue arrow is negligible.
Sir, why?
Because this is not given. I mean, the wedge, we are actually assuming that this view that we are seeing is exaggerated view. Actually, this block should have been somewhere here, that it has just started to penetrate the system. I mean, the correct figure would have been something like,
Sir, which question are you discussing?
1 minute.
Ninth one.
It is actually something like this, okay, where it has just started to lift it, not exaggerated like this. Okay, when this happens,
Okay, sir. Got it.
this distance is actually negligible. Once this fact is known, I think this is not a very difficult problem. Then you can, so what it means is that, let us, if I draw the free body diagram of this block, I am going to have AX, AY, BX, BY.
So
The
are we to consider the block to be horizontal?
almost, so the distance between AX and BX, the perpendicular distance between AX and BX is negligible.
Okay, so okay.
Then I think you should normally be able to solve it. Okay.
Sir, why you considered AX and BX? It should be a normal perpendicular to the wedge.
Yes, sir.
No, but AX and BY is something that I am defining. Now, it for a certain, any resultant A, the resultant A is perpendicular to the wedge. That I can agree. The resultant is A is at an angle phi s from the wedge, but it can still be broken into AX and BX. Why not?
So then only
Yes.
one is unknown. Only the magnitude of A is unknown because we know the angle.
Yeah, but I mean, I did it like this. So is my PDF visible?
Yes, sir. It's visible.
So in this question, the wedge is just inserted. So this is the point I was trying to make here, that the wedge is actually just inserted. Okay. So the difference in line of action between AX and BX can be ignored. So the free body diagram will look like this for the block, something like this for the wedge, at an angle phi x from the perpendicular, but this degree is already 5 degrees. We know that. Okay. Now Then I have done summation MB is 0. Moment about point B is 0. Gave me the value of AY. Tan phi s was known from the free body diagram of the wedge. I can solve and I can get the answer. Okay. Most important concept is the free body diagram of the wedge. That if you understand more or less, and if you realize that the wedge is actually a 3/4 member, then it should not be very difficult to solve this problem or problems like this.
Sir, how did we find phi s?
Phi s is tan of mu s. Tan inverse mu s, sorry.
Sir,
Yes.
sir, in this question, we are assumed that impending motion is occurring at all contacting surfaces except that about which we took torque. Because if we want to slide the wedge just below the block, then the wedge must be having impending motion above the ground, and the block must be having impending motion on the inclined side of the wedge. Means AX AY means we at the contact A, we are assuming friction is mu n and not some other lesser value. That is my question.
I think since this body is rigid, if it is moving around A, it will move at B simultaneously. Not necessary.
No.
No. So we are saying that it cannot slide about B. Only thing that can happen due to my wedge is that this angle can go up. Like so. As I push
Please
this
explain
wedge,
once again why it can't slide.
as I push this wedge, this is what is going to happen. This is what we are saying. This point we are saying is not changing.
Sir, my doubt is that
Did we prove that?
the friction. Sir, we are having friction at three surfaces. Okay, between the small wedge and the ground, at point A and at point B. So what I am asking is that the friction at point A and the friction between at the ground, that will be maximum friction, no sir, maximum possible friction. While solving the question, we will take it as mu n only, no?
So you are saying there is friction here. I am putting circles, okay, where what if I understand correctly, okay?
Yes, sir.
There is here. There is friction here, correct?
Screen is lagging a bit. Yes.
Okay, now what happens?
Sir, my doubt is that we assume that friction at the left two circles, sir,
Yes.
is impending friction. While solving, we can directly put that or not, or we cannot do that. That is my doubt.
Let me think.
Because sir, it should be impending friction because we are taking tan phi as mu, which
Mu,
means
yes.
we are assuming impending motion only, but that is not quite evident from the figure that it will be impending.
You are saying that if I apply a load, P here, shown by the red arrow, it is possible that this thing can move like this. Yes? This possibility we are ruling out. Is this your question, that this movement we are ruling out?
No. Sir, my doubt is simply that when suppose I assume friction F2 and N2 at point A, let us assume that normal reaction is N2 and friction is F2 at point A. So can I directly, while solving the question, use the equation F2 is equal to 0.2 N2 or not? That is my doubt.
For equilibrium, yes, now that is the whole point, that it is about to get lifted up. It is in a state of equilibrium. If I increase P any more, then this block will start to rotate. So yes,
Okay,
I
sir.
think what you are saying you can do.
Okay, sir.
Sir, once you said about normal reaction,
Your voice was not clear. Can you please repeat? Hello?
So I have doubts regarding the friction. Where how to consider that where is impending motion? So at B or A, sir. If you don't know anything.
No, but how can it be that it is? So you are saying that there are two possibilities. One is it can move like this, correct?
Yes, sir.
And the other is it could go like this, as this goes.
Yes, sir.
So how do we know that? Why did we rule this out? Why are we saying that this is not going to happen? That this movement, I mean, this movement has been neglected. I don't know. I can't seem to think. This is good question. Let me come back to it. Okay, I will discuss. I will come back to it.
So we are discussing the translation of the rectangular.
Why exactly? So why is the translation case ruled out?
Sir, we can calculate it by using the force on A if its x component is less than mu b.
median बराबर क्यों है?
Sir, if its value is less than mu b, then it won't translate in x direction.
Can you come again? Can you repeat, please?
Sir, we can decide that rectangular block moves or does not move in x direction by calculating the x component due to force at corner A and calculating its x component, whether if it is less than mu times normal at this point. If it is less than this, then we can calculate that if does it moves or not. And we can calculate the normal at B by component by 6200 minus AY component. I think we can calculate it.
Excuse me, sir.
Yes. Somebody was saying something.
You said about normal reaction, how it acts perpendicular to the surface, or like two types you told us. Can you repeat it?
This was my favorite. I said, irrespective of how the resultant A is passing through, I can always break it to AX and BX, AX and AY. If I write friction force as AX and AY, if I write forces as AX and AY, it is only a function of the coordinate axis system that I choose. So while drawing the wedge, then the resultant A will pass at an angle phi s from the normal, that is agreed. But this does not stop us from breaking it into two components, AX, AY. Okay?
Okay.
Yes, and then basically once you have the free body diagrams, I have done summation MB is 0, got the value of AY, phi s is tan mu s. This I will come back to you why this assumption is made. And from the free body diagram of the wedge, I can write summation Fx is 0, Fy is 0. 3 equations, 3 unknowns I can solve. I got a number that is slightly different from the answer that is given in the problem sheet. In the problem sheet, answer is 854.1. I am getting 872.6. Has anybody able to solve this problem? And yeah, no slipping condition can be satisfied by comparing the value of P with mu s n. If mu s n is greater than P, then the system is not going to slip, or I think there will be no translation motion. I think this was the question that was asked. Yes, I have checked it in the end that there is no slipping.
Yes, sir.
But
Same
this,
answer.
can anybody confirm this to me? 872.
Yes, sir. Yes, sir. 872.62.
So this answer is wrong, na? 854.1.
Yes, sir.
Somebody was asking question about no translation motion. Does this last point satisfy what you were trying to ask?
Yes, sir.
Okay, good. Okay, wedges are clear for everybody?
Yes, sir, more or less. Yes, sir.
Yes, sir.
One more small doubt.
Tell me.
Once you told the direction of normal forces, two cases. Once can you repeat that?
Direction
Which
of?
direction that depends? No.
I told, or it was told in the video?
You 2 weeks back.
2 weeks back, I told. In what context?
Three or 2D equilibrium.
3D or 2 equilibrium.
It
Then
depends on the object. Depends on the object, whether it's big size or small size.
it is. Oh, I see.
How
I
to
see.
consider the direction or not.
Understood what you're talking about. So I think we were talking about. Let me. 1 minute. Let me search. This slide, yes?
Yes.
So basically the rule is if there is a object which is resting on a wall, the direction of the resultant force is normal to the object that is taller. For example, in this case, the wall is taller than this point. So the wall is above this A point. So this reaction is normal to A. On the other hand, in this case, the reaction is going to be normal to my crate, because this crate is resting not at the tip of the crate, but the crate is extending far beyond the contact point. The one who is taller, the reaction force will be perpendicular to that. Clear?
Yes,
So in
sir.
that
Thank you.
question, the rectangle, the normal would be perpendicular to that rectangular box.
In the second case, yes. In the case that my above which my pointer is currently, in that case, yes.
Answer in the question 9.
Question 9 of what? Which
What we
question?
just of wedge question.
Yes.
In that case, also the normal would be perpendicular to rectangular box.
Yes, but sir. There is friction, na? There is friction. This is in this problem that we were discussing, there is no discussion about friction. This is smooth surface. Okay? If there is friction, then it will depend on so many things, whether what is the coefficient of friction, etc. In 2D equilibrium, we were talking of situations without friction.
And sir, I have a doubt regarding that phi s. What is the use of that in our question?
Phi s.
It's a tan inverse mu.
In the context of wedges.
Yes, sir.
To write the equilibrium equation for the wedge, you need the direction of A and R. The equation equilibrium will look something like this. Summation fx is 0, summation fy is 0.
Okay, sir.
Okay.
Yes, sir.
Okay. If you have already solved the problem sheet on friction and you would like to solve more problems, last year's problem sheet. So this year's friction problem sheet has been simplified much easier. I mean, so this year we have remade the problem sheet where we removed some difficult problems from the friction problem sheet, made it much simpler. So if you want to practice some more, and if you are able to get hold of the problem sheet from the previous year of friction, there I think you can find few more challenging and interesting problems. But first finish this, then only go to that problem sheet. That would be my advice. Okay.
Sir, where can we find that problem sheet?
Did you not? Did you get it from your seniors or from your mentors or anybody?
No, sir.
We got it, sir.
Those who have got it, please share with everybody. Don't. I think it will be better.
I mean, the mentors have only given us.
So if you have it already, Samyak, please give it to them.
Yeah,
There is excellent app, student mentor group for that. There we can find many materials from previous year.
Yes, sir.
Okay, but last year screws and nuts were not there, so that is the new topic that has been added, and the rest of the problem sheet got much simplified. Okay, now the next problem we want to solve is about belt friction. Problem number 12, 13, 14, 15. So, do you understand belt friction more or less, everybody?
Yes, sir.
Yes.
Yes, sir.
Yes.
Very simple problems, huh? So now, after going through the video, could you solve the horse problem that we were discussing last week?
Yes, sir.
There was also a question that friction is independent of area, so why we are counting the loop? All those doubts are clear, I hope, yes?
Yes, sir.
Okay, good. So now, which problem should we solve? 12, 13, 14 or 15? I have solved
13.
13 I have solved. So in problem number 13, you have a belt drive which is subjected to mass. This is having friction. You apply some moment M such that one of the arms of the pulley makes angle 20 degree. We want to find out what is the friction. Okay. So how will we solve it? Let
Hello,
us
sir.
draw.
Sir, your screen is not visible.
Oh, sorry. Yeah, so we are looking at problem number 13. Okay. So in problem number 13, let us draw a moment is applied. Now the entire thing is shifting such that one of the arms of the pulley is making an angle 20 degree. Okay. Now we want to find out what is the friction between the cable and the pulley. For that, we have to draw the free body diagram of this ring at A. Okay. Draw. So it will come out to be something like this. T2, T1, mg. This angle theta is given. So can you solve for friction?
Sir, the T1 string shouldn't have been slacked.
T1 string, yeah, it can slag, yes.
Sir, then how can we consider the formula to be valid?
No, it is not, perhaps it is not slagging. It is, I mean, it is still non-zero. It is some positive tension.
Sir, as soon as the figure moves from certain different direction from the center position at A, so shouldn't the lower string always slack?
You can try to solve it, get the value of the tension and then find out whether it is positive or negative.
Okay, sir.
Sir, can tension attain negative values?
In a cable, no. A cable is incapable of taking tension which is negative. And even by your belt drive equation, what do you have? T2 by T1 is e to the power mu beta. If T1 is negative, what happens to T2?
Yes, sir, it will also be negative.
Yeah. So it is not possible that one is negative, one is positive.
Okay, sir.
Okay, so this angle is 20 degrees. So the Freeburg diagram will look something like this: T2, T1, 20 degree, mg. Now we have how many unknowns? T2, T1, and that is it. We have two unknowns. So try to solve it. Find out the ratio between T2 and T1. Get the value of mu. I think this is a problem which requires less than 2 to 5 minutes to solve. So T1 is mg sin theta, T2 is mg cos theta. Also T2 by T1 is e to the power mu beta. So what is the value of e to the power mu beta is 2.74, which is 1 by 1020. From this you can get the value of mu.
Sir,
Yes.
sir, I have a problem.
Yes.
Sir, in the question number 9, I am getting 854.01, which is given in the tutorial, but your answer is different.
Can you take a picture of it and send it across?
Yes, sir, I can do that.
Okay, is it clear? This problem that we're talking about. Chirag, do you have a question?
No, sir.
ठीक है. Were you able to solve problem number 15? Step by step, can
Sir,
anybody? Yes.
sir, in 12 they have given mu. It
In which
asks
one?
seconds. Question 12. mg by 5 answer.
Question number 12. Yes. If force P is equal to mg by 6 is required to lower the cylinder at constant slow speed, making 1 and 1/4 turn. So this is 1 and 1/4 turn means what? What is the value of
5 by 2.
5 by 2.
5 by 2? So yes, what is the problem in this question? So they are saying that
They have given mu in the answer and asked the question of P.
no,
Sir,
this is
mg
wrong.
by
If force
coming,
P is required is already given, na? So how can you calculate the force P?
Sir,
in second case, yeah.
To raise it at slow speed. So yeah, you have to first calculate mu, and then so basically I have T2 by T1 or m divided by mg divided by mg by 6 is equal to e to the power 5 by 2 pi into mu. From this I will calculate the value of mu. It will come out to be 0.228. Now I have another problem which says P divided by mg is equal to e to the power 5 pi by 2 into mu, thus calculated. Find the value of P.
So directly can't we say the factor e की power mu theta is 6? Now it would be 6 mg.
Yes, sir.
Yes, yes. But I think the question should have been calculate the coefficient of friction and the force P. Otherwise, yeah, what you are saying basically is right. Questions like this are very common in the GATE exam. Do you know what is GATE exam?
sir, for N with
Yes,
M.
Yes, sir, for MTech exam.
Yes,
This
sir.
Not only IIT.
this is for private message. This is for private sector, public sector units as well as for MTech. So in this,
Yes, sir, for
they
PSUs
they
also.
ask a lot of questions, but very quickly which you can solve. Like if the coefficient of friction is not, if you don't want to know the coefficient of friction, then P is 6 mg. It is straightforward. But yeah, I think this question is incomplete. It should have been calculate the coefficient of friction and the force P that will be required. And you are right, to raise it, it has to be 6 mg. Okay. Good. So question number 14, 15 done.
Yes, sir. So
Yes,
down,
sir.
I doubt in 16, sir. So 16.
But wait, belt friction is complete for everybody. Everybody is comfortable with belt friction. I think of the different topics in friction, belt friction perhaps is the easiest. Yes.
Yes, sir.
Yes, sir. Pretty straightforward.
And the calculations are
Sir,
also much easier. But now you guys are lucky in the sense that you are only getting a question. When I was a student, pata hai what would be the question? They would give a question like this, and below every question it would be written, derive all the equations that you use. So
in the
you are
exam,
not
sir.
allowed to take any formula. So because of that, it would be very long and very difficult. Now that sentence is no longer present in any question, but 10 years ago when we were doing it, it was like that. So belt friction also.
Sir,
we
in
had
your
to-
exams as well.
Hmm?
In your exams as well.
In our exams, in the question paper, it would be written, derive all the equations that you use.
How did you use to complete your paper, sir?
And but it will be slightly different. Like in when we were students in my engineering mechanics, it used to be there would be 10 questions, do any 6 that you like, and those 10 questions would be very difficult. I mean, the problem sheets that you have today is much simpler than the problem sheets that I have solved as a student. Very difficult, tight questions, but 10, do any 6 that you like, derive all the formulas that you use. So mechanics would be very difficult for us. But at the same time, you could strategize. Out of 10, you could do any 6 that you like. So it was different times. We were less students. We were only 30 students in the class. So we could actually discuss what we have done, what is going on. But times have changed. That time Moodle was not there. Okay.
Sir, that time Corona also wasn't there.
Corona maybe has been there. It's just like common cold. I think 4-5 years later, Corona will be there. Some other virus was there. Coronavirus means a virus which has a crown. Coronavirus was there. Novel coronavirus was not. But okay, never mind. We have to, we have to play with the cards that have been dealt with us. Okay, so now let us look at question number 16. Okay.
Sir, in 15, excuse me.
Which one?
15.
15 you could not do, is it? Achha. 15,
Sir, I have doubt that why P is minimum. P should exactly be that, no? For to be in equilibrium.
To prevent the wheel from rotating. When will the wheel rotate? What is the condition? So this condition, not T2 by T1, is that the wheel is not rotating. It is almost about to rotate, but not rotating. If the P is higher, then it will start rotating. This T2 by T1 mu, that equilibrium, it is no longer in a state of equilibrium, the equation that you are using.
Yes, sir. Okay.
But otherwise, this is a simple problem in the sense that it is slightly longer than the previous question, but it is simpler. First, draw a free body diagram of this circle. Let me share the screen. Okay, so first draw the free body diagram of this red circle. Then you will get something like.
Sir, in this diagram, can you please tell in which side T1 or T2 which will be higher?
Can you see this?
Okay, sir. Okay, sir. T2 is. Yes, sir.
So first I took the free body diagram of this red part and equation the moment about m. I will get T2 minus T1 into, wait, this should be 0.225 into radius is equal to 150 Newton meter. I get some value of T2 minus T1. Then I will draw the free body diagram of this orange beam, this blue beam, take moment about 0.0 and we can solve it. You have three equations, three unknowns. Three unknowns means T1, T2 and P. And you have three equations, meaning the first equation is coming from the free body diagram of this red flywheel, center moment about the center. And now if you have, take the blue bar, take moment about point O and also summation Fy is equal to 0. Or the another equation also is T2 by T1 is e to the power mu beta. E to the power mu beta summation of MC is 0 and moment about point O is 0. Three equations, three unknowns, you can solve it. T2, T1, P, all you can get. Okay, clear?
Yes, sir.
Actually, if you are looking at it from a purely an equilibrium point of view, how many unknowns are there? T1, T2, P, OX or OY. All the forces are, we have four unknowns, but there can only be three equations of equilibrium. So what do? I need a fourth equation, and that fourth equation is coming from belt drive friction. So then I have four equations, four unknowns, I can solve for whatever I want to solve. So you can also, I think, look at friction from this perspective. A lot of time friction is actually something like that we want to solve a problem, equilibrium problem, and there are not enough equations. So you have four unknowns but three equations. The fourth equation is going to come from the laws of friction. That is also another perspective.
So I have a question about question 9. So I solved all the equations, but the answer of P I'm getting different. Like I'm getting 872.62, not according to the answer that they have given.
That's what we discussed in the class also.
Yes, sir. I actually wanted to know the value which was being discussed. I forgot the value only.
I got 872.6.
Yes, sir, I also got that only. So, but by a different, a slightly different method. Like I considered the normal and all in the directions perpendicular to the surface.
One of
and all.
our friends has got 842, 854, which is the answer corresponding to. Chirag has got the answer. So.
Sir, actually, I discussed with Aditya, who got the answer same as yours, and then we found out that I have actually in that N2 actually the movement part. I have not taken the moment of friction. I have taken the moment of only the N2 part and the mass of the machine only.
So this answer that you have shared is not correct, is it?
Means actually, sir, you told that the machine will be almost horizontal. So I thought that the movement due to friction won't come.
But your answer is incomplete, no? It is abruptly stopping. Or did
Sir,
you
after that I have put the values in my calculator. It was coming 852, 854.
Okay, let me study your answer. I will get back. Question number 9, you can expect some more input from me. Okay.
Okay, sir.
Okay, good. So final question of this topic, friction. Let us look at question number 16. 40 millimeter diameter screw.
Sir?
Yes.
Sir, can you please explain question number 11? I wasn't able to solve it. I didn't understand.
Number 11. I did not solve this problem as preparation for this class. Okay, let me. You will get the solution. I will explain it. Okay. So a 40 millimeter diameter screw has a double square thread with pitch of 12 millimeter. Everybody knows what is pitch?
Yes, sir.
And
Yes,
lead,
sir. No pitch, but so lead is strength
Yes, sir.
for
Explain lead. L equals NP, sir. I won't get what is N. How are we calculating those things?
huh? Come again. What is your question?
So what is the lead, sir? Actually, I didn't understand about lead.
So let us open the presentation used by Professor.
Sir, and how you can determine the direction of means whether to use tan alpha plus phi or tan phi minus alpha?
Yes, sir. Means in each, whenever you apply moment, the how to determine the direction of friction and normal. That is a very difficult job in all screw questions.
Means value is very easily found, but the problem is in the use of tan.
Did Professor Maiti
Same
not,
here also, sir.
Professor Maiti did not explain that?
Sir explained, but not properly, sir.
Okay, I think you should read the presentation because he has explained, and then if my explanation starts conflicting with his, it will be a problem. I can request him to send some sort of extra handout, but I think his presentations had a lot of text. Yes, by reading that you could not understand.
So your explanation are much better, sir.
Yes, sir. So it will be
Yes, sir.
too
Yes, sir.
better, sir.
You will not believe that Professor Maiti has been teaching for longer than I have been alive.
No, but sir,
But
if
sir,
you
you are a
explain
great
advanced
teacher,
it's
sir.
gradual.
Great professor.
Sir, you explain better. That is the thing.
I think we should do it yours. I will talk to him, but I think it was more or less decided that theory, as far as possible, has to be.
Sir, there are two forces. Sir, what is the difference between the weight or load on the screw and the internal force that is there on the screw?
I am uploading his presentation. Okay. Now tell me. Yes. So in this slide, what is the problem?
Sir, lead and lead angle.
Lead angle alpha is the angle with pitch and the thread. This angle alpha. Can you see?
Yes, yes, sir.
So lead is the distance by which screw advances in one full turn. Lead may lead.
Sir,
Lead is the distance by which screw advances in one full turn.
sir, can you explain multi-start screws? Like it's very difficult to visualize.
A multi-start thread. So to understand what multi-start thread is, open a bottle, any cold drink bottle, and try to count the threads. Most of the times it will be 3. Just by inspecting that, I think it will be clear.
Yes, sir.
Now don't ask me why it is 3, why not 4, why not 2. All that you will learn much later, but most of the times it will have 3 threads, and that is the concept, I think.
Sir, can you explain V threads and square threads, please, sir?
In our syllabus, we are only looking for square threads, and V threads, square threads, mechanical, manufacturing, aerospace, 6th semester, it is a little bit more complicated. From where you are today in your engineering, I think it might be difficult to understand. So for this, we just look at screw threads. If you belong to mechanical, manufacturing, or aerospace, we will see you in the 6th semester and we will discuss this in detail. Which department are you in?
Some mechanical, sir.
Good. हाँ तो ठीक है. 6th semester. Most likely, I will only teach you design of machine elements.
So in the 6th semester, that means third year only we will learn all this.
This is, I think, so this was only because we wanted to have applications of friction as opposed to design. I mean, so the same thing you can study from the perspective of designing something, and the same thing you can study from the perspective that you want to understand friction better. In this course, our objective is the second one. And if your objective is the first one, that you want to design how screws are made, how threads are made, that will require not only knowledge of mechanics that you have so far, but other things also you will need to know. So logically, that should happen in the 6th semester, because by 6th semester, in your 4th semester, you would have done a course on mechanics of solids. In the 3rd semester, you would have done a course on dynamics. Once these two is known, understanding what is V thread, what is square thread, why we are doing, all that will become much easier. Also, another important thing to know to understand this completely is how are screws made? What is the manufacturing process? So without knowing all of this, if we start saying what is a V thread, what is a square thread,
So
then
we have actually
you'll
a
only get
bit
more
of machining in the first. We have a bit of machining done in the first
but
semester itself.
usually you'll have one more course on manufacturing. This
Oh,
machining that you are learning is for the complete engineering.
okay, sir.
Have patience. I am happy that you are inquisitive, but
Yes, I'm
it will happen.
excited because
It will happen. Okay, so
Sir, in the slide,
which slide?
sir, in the next slide, confusion is whether to use tan alpha plus phi or tan phi minus alpha.
Same doubt, sir.
Hello, sir. You are not audible.
Sir, I think the screen hanged.
Is sir audible?
No, I can't hear him.
Yes.
No,
Some-
no, I
no,
can't hear.
no.
Internet problem.
Some problem will come soon.
Yes, sir. Video was also lagging.
डायरेक्शन कैसे पता लगाते हैं स्क्रू से?
यार सबका ही तो डाउट है.
अच्छा ठीक है.
So it's saying broadband connection is out. So
Am I audible?
yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
For
Yes,
one,
Yes, sir.
then it went out. So where were we? We were discussing that there is some problem in the presentation that he has sent. So let me share the corrected. Okay. Share the screen. Share. So is my screen visible?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
In one of these slides, I think in the second last, in this slide, I think the direction of F was wrong. Did he discuss this yesterday?
Yes, sir, correct.
So this
Sir
is the,
uploaded a correct one.
this is the correct one. So just I am saying this now. What was the question?
Yes, sir. In how to identify the cases where we need to use tan phi minus alpha or tan phi plus alpha?
So is it because of the fact that for upward motion of the screw or downward motion of the screw?
Sir, and in the horizontal orientation of the screw?
Is sir audible?
No, sir. Yeah. I think sir connection
Uh,
again disconnected.
Connection.
By the way, today there are extra class of math, like 5 to 6.
Yeah, and also physics
No,
of
it's of physics of waves, I think.
The same.
I got mail.
नहीं वो तो है ही, but Nahak sir also told that he would be taking a math class from 5 to 6 extra class, mandatory for everyone.
Yes, but
हाँ वो
now
थर्ड
which
क्लास का
will be
बोल रहे
attend
थे बस, लेकिन उसका कोई मेल नहीं आया ना.
now which class should we attend?
ऑब्वियसली फिजिक्स, क्योंकि कल उसका टेस्ट है।
संडे को मैथ्स
यार मैथ्स का बाद में लेक्चर देख लेना ना।
About math.
रिकॉर्डेड मैथ्स तो आसान है यार,
मैथ
फिजिक्स
को
मुश्किल
रिकॉर्ड
है.
करके बाद में देख लेंगे।
सर
सभी वही करने वाले हैं।
फिजिक्स में डाउट बताएंगे।
और एल्स ऐसा करेंगे कि फरवरी में मैथ्स की लगा लेंगे.
यार मैंने सुना कि इस बार नेविगेशन नहीं देंगे मैथ्स में।
हाँ नहीं देख
बिना नेविगेशन कितना टफ था, तो अब कितना टफ है।
अरे मैथ का कोई ज्वाइन ही मत करना, पढ़ाएंगे किसे?
हाँ बाद में बोल दो ना कि फिजिक्स का मेल आया था और मैथ्स को भी मेल ही नहीं आया था, तो मेरा मैथ्स की क्लास ही है वो, मतलब फिजिक्स की क्लास ही है.
हाँ हाँ सही है. हाँ ये सही है.
Big brain.
यार मैथ्स में तो सर वैसे भी आगे चल बहुत। Physics sir भी.
Can anybody tell
Maths.
me the math syllabus clearly?
मैथ
Because
कितने तक
some
आएगा
are
ये पहले बात.
तुम सबने
Beta
फिजिक्स
gamma,
सबमिट
beta gamma, beta gamma.
ठीक
तुम
है.
सबने
सर
क्या
ने
assignment submit
उतना
कर दिया?
तो
बीटा गामा में फंक्शन भी है ना?
वो पैरामीटर वाला इंटीग्रेशन. हाँ
पैरामीटर यूज टू इंटीग्रेशन एरर फंक्शंस जो अलग से होता है.
पैरामीटर
वो
वाला भी
आया.
आएगा. पैरामीटर तो शायद
error
नहीं आएगा.
function
वो सब नहीं
सर
आएगा
ने तो
शायद.
बीटा फंक्शन तक का बोला.
मेरे को लगा कि
पैरामीटर आएगा.
बेसिक बीटा गामा ही आएगा शायद.
हाँ
तुम सबने सबमिट कर दिया फिजिक्स असाइनमेंट फिजिक्स का?
हाँ
मैंने कर दिया.
हाँ.
आज
ये
लास्ट डेट है. कर दे
भाई.
भाई.
वैसे
कर दो
मैथ्स क्या पूरा क्यूमुलेटिव है, मतलब पीछे वाला सब कुछ आएगा क्या?
हाँ हाँ
Yes.
सारा.
हाँ बीटा गामा तक सब कुछ आएगा.
सर ने हमें सिलेबस और टाइम कुछ भी मेल नहीं किया ना.
हाँ
हटा दिए सर.
फिजिक्स टेस्ट का टाइम कब है?
3 बजे से.
3 बजे.
मैथ्स का मॉडल पे कुछ दिख रहा है क्या?
एटलीस्ट सुबह 7 बजे नहीं अच्छा है.
मूडल पे एडवांस कैलकुलस का कोर्स ही निकलवा दिया सर ने.
मूडल का 9 बजे से है ना?
हाँ सर बोलते कि मॉडल पे देखो.
मैथ्स का 9 बजे से है.
9 बजे से बोले थे. 9 बजे से. यस.
हाँ
9 से 9:40.
दिखा रहा था वाला.
फिजिक्स का टेस्ट मॉडल पे होगा या फिर कहीं और?
दोनों का मॉडल पर है सर.
मूडल पे. इंजीनियरिंग लैब का भी कब है क्या पेपर? संडे को
29th को है.
29. अच्छा ठीक.
सेक्शन 1 सेक्शन नो सर. हाँ सेक्शन 2 पता नहीं.
तो सच में छुट्टी नहीं है.
ईवी का प्रोजेक्ट भी है भाई 31 को.
वो स्टार्ट किया.
कौन है जो शुरू कर दिया?
हाँ कोई है जो शुरू
जिसने
किया.
शुरू करा है वो एक बार भेज दो ना. मतलब
ठीक है.
भेज दो ना
I
मतलब
think बहुत
EVS?
सारे होंगे तो complete कर चुके.
भाई डिफरेंट सिटी है ना सबका, कैसे भेजे?
रिकॉर्ड हो रहा है. मूडल पे मैथ्स का सिलेबस कहाँ लिखा है?
मॉडल पे मैथ्स है ही नहीं.
हाँ लिखा ही नहीं है मूडल.
हाँ वही किसी ने बोला अभी कि
प्रोजेक्ट के पहले क्यों डाल दिया चैनल को?
I guess sir is back.
ही नहीं बताए कब है.
मूडल पे से मैथ्स कहाँ चला गया?
बोला तो था सर ने निकाल दिया.
तो अब कहाँ पर देंगे
सर टेस्ट
डिटेल्स?
कैसे करते हैं? अच्छा भाई हम सब बातें कर रहे हैं, ये सब रिकॉर्ड हो रहा है. क्या ये भाई ने प्रोजेक्ट का मेल किया है क्या?
Everyone please be quiet. Sir is back.
Thank you. So what were we discussing? We were discussing
Screws.
screws. Yes. Why it is not good? Friction, coils, corrected. So yes, so we were discussing lead and pitch. That was done, and then somebody was asking upwards or downwards why it is. Should it be theta plus phi or should it be theta minus phi? है ना?
Sir, is moment
Yes, sir.
so.
Yes, sir.
Most of the question is horizontal in direction, orientation.
I did not understand. What is horizontal?
That means in questions the screws are placed in a horizontal orientation, so we cannot get whether it is upward motion or downward motion as mentioned here.
Ah, okay, okay. So No, why not? Upward or downward, it can still be right or left.
Sir, but means like in the question you are going to
Because
solve, we got the
there is
value.
no there is no question of gravity. Yes, upwards or downwards, right or left means the same thing.
Yes, sir. We can simply consider inward outward.
It is actually inward outward. That is
Yeah,
the
that,
right word. Not upwards downwards. It is inward outward.
So, but from which side we should take that it is inward or it is outward, sir?
I think upwards is, so this block, blue and yellow block, is coming towards the applied moment. That is upwards, away from it is downwards. That is the concept, I think.
Sir, we can keep in mind winding and unwinding means if it is screw is मतलब अंदर जा रहा है या बाहर आ रहा है वैसे.
Exactly, outwards, inwards, वही है.
Okay, sir. So can you discuss that
I
question,
think
sir?
the feeling I am getting is the visuals are maybe not nice. तो ऐसे करते हैं कि I will request Professor Maiti, or I will do it myself or with the help of other teachers. We'll put in some more pictures, make it more clear graphically, I think. है ना? Okay?
Yeah, sir.
I think it is, yeah. These figures are
Can you
very abstract, I think.
go to the example that was in this slide, last
Sir,
example?
I have one suggestion.
Yes, what is the suggestion?
Sir, actually, our physics teacher, professor, uses animations to describe some concepts. So, like, if in BM animations could be included, that would be great.
ठीक है, I will. I'm making the material for the next topic, which is the next to next topic, which is stress. I will keep this in mind. I will also convey. I think, but other than friction, we did not really need animations for any other topic, right?
Yes, sir.
Yes, sir.
yes, yes, sir.
In stress, I think it will be there, but thank you for the suggestion. I will do it. So now in this, the moment is applied here. So is this screw coming towards this moment, traveling towards this applied moment, or going away from this moment? This is the inward and outward concept.
Oh, sir, that was not my doubt. Actually, my doubt was how the equation was written m equal to 2t. Because in the free body diagram 1, it is getting cancelled.
Two pin arms. One minute. Braking mechanism consists of two pinned arms, the square-threaded screw with light, right and left-handed thread. Okay. Screw is 4 millimeter, mean diameter is 12, mu is this much. Determine the tension. Free body diagram 1 shows shown response but not applied. Free body diagram 1 shows the tensions in the screw and the element shown is responsible to create the tensions. In free body diagram 1, there are two tensions, yes?
Yes, sir.
But
Yes, sir.
so this equation is coming from free body diagram 1, not free body diagram 2.
I was saying free body diagram 1 only.
In free body diagram 1, if I take moment equation, let us say about some point, then will not the moment will it not add up? Why should the moment cancel each other out? You are saying m should be 0, is it? Or 2t or 1t or 0t?
Sir, if I see, actually the screw is not connected at the middle. It is separated somewhat. So if I consider
No,
for
this is
only
I
one,
think only graphical. This is graphical. It should be 1, like it has been drawn here.
sir, even though it would be one, then the black thing that is connected to the screw, that it would be connected in only one side. So the tension will be either on the left side or right side, the resultant tension. So it will automatically cancel out.
I don't know. I will have Professor B. Maiti answer these questions. I will note it down and he will get back to you. Okay?
Okay, sir.
Okay. Okay, then I think this, let us leave this pending. I will request him to send some more materials, or we'll arrange something for you for belts, I mean for the screw. Apart from this screw, everything is okay in friction?
Sir, the tutorial question.
One at a time. Is tutorial
Sir, you
complete?
are going to solve the screw question in tutorial. That can help.
No, but that was just, we are using just the formulas that I. Okay, let's see what I have done.
So, but we will understand which formula should we apply at which condition if you give the solution, sir.
So today's assignment will contain question from this topic.
So this is what I had done. I first calculated the helix angle, then I calculated the friction angle. If the friction angle is less than the helix angle, then the screw is not self-locking.
So your screen is not visible.
Screen.
No, I have shared it.
No, sir.
No, sir, it is not visible, sir.
No, sir, we
No,
can't
sir,
see
it's
it.
not visible.
Sir,
It is saying that I have shared something. Stop sharing. Now?
No, sir.
No, sir.
No, sir, only participants are visible.
Now?
Yes, sir.
It
Not visible.
came.
Yes, sir, it
yes,
is
sir.
visible.
So
Yes, sir,
basically,
it is
step
visible.
by step, helix angle is calculated. Tan inverse 24, I think was, what was 24?
So lead, sir. It was lead.
So 24 is the lead. So helix angle is lead divided by 40 pi. 40 is the screw diameter. Lead divided by screw diameter into pi is your helix angle.
Sir is
Hello,
again
sir.
gone.
Hello?
Hello, sir.
Somebody, somehow I got out of the meeting again. Yeah. So look, first I get, is my screen visible now?
Yes, sir.
Yes,
Yes,
sir.
sir.
So first I calculated helix angle based on the diameter and the lead. Okay. Basically lead is how much my entire screw is going to move on one complete rotation. So based on that, I can calculate the helix angle. I calculated the friction angle greater than the helix angle. So the screw is not self-locking. The motion is unscrewing as described in the question. Then I have this equation. I solve it. I get the answer P.
Sir, unscrewing here is right or left?
If it was screwing, it would be phi plus alpha, I think.
Yes, sir, but the unscrewing part is right movement or left movement?
It is the A, the force required to advance the shaft to the right. I have solved that part. Unscrewing is this.
Sir, because these two options, if we consider right or left only, would come opposite to the one explained in the slides.
Okay, I think let us not discuss this. I think there are some complications I understand. So let me get
Sir, you are not audible, sir.
So please, if you can, please extend the deadline of the assignment to Monday or Tuesday.
Sir is not
I
in the meeting.
think yes, sir cannot hear you. You have to type in chat box.
hello.
Yes, sir, you're audible.
Yes, sir, you're
Hello.
Yes, you are audible.
Yes, sir,
Yeah,
you're audible.
the internet at my end is very poor today. I am barely able to do anything with my phone. The broadband is not working. So we'll have our class. I think we'll continue our discussion on threads maybe next week. The topic for next week is a little bit light. So half an hour we can continue our discussion on friction. And so for now, let us close this lecture, okay?
Yes, sir. Thank you, sir.
Yeah. Yeah.
Hello?
So deadline of assignment, can you say?
1 minute. Hello? I am
Yes, sir.
unable to hear you.
Date of submission
The
of
assignment.
assignment.
So assignment number 5 is today, is it? It was meant to be out today. I will try to get it
Yes,
postponed.
sir.
Okay. I will try to get it
Yes, sir.
postponed. Maybe it will.
But the
Yes.
section is like, oh, okay, sir.
So I mean, it will.
Yes, sir. It was
most-
out, sir.
It is already out.
No, sir.
No,
It
sir,
will
it
be out at
isn't.
4
At
p.m.
4:30.
But I can see in Moodle 5, sir.
In Moodle, assignment 5 is out or not out?
Now it is not. Now it is not
Yes, sir. Yes, sir. It is out.
It will be available at 4:30, but we cannot
Yes,
access
sir.
the assignments now.
Acha, okay. Let me talk to the overall coordinator. At least I will try to shift the end date.
Yes, sir.
Okay.
That will be
I will.
upgraded.
You will get an update in the Teams. Right now, I'm barely able to hear you, or nothing I can do from my phone. The internet is E. So, okay, Tuesday or Wednesday we'll have an half an hour discussion on this topic.
Thank you, sir.
Okay.
Thank you, sir.
See you. Have a good weekend.
Sir.
Thank you, sir.
Thank you, sir.
Have a good weekend.
Thank you, sir.
Sir. Excuse me, sir.
Thank you, sir.
Sir, leave this meeting.
Class is ended now.
Yes. Please, to stop the